Hi everyone, good day to all of you. Today I'm going to share some notes regarding the topic enzyme inhibition. So inhibition of enzyme may be the irreversible or the reversible. Irreversible includes the competitive, non-competitive and the uncompetitive. So in irreversible inhibition, the Vmax is equal to 0 and the Michaelis momentum const is equal to constant. So inhibitors bind tightly to the enzyme and it dissociates very slowly from the enzymes. In suicide inhibitor, the inhibitor binds to the enzyme as a substrate and it is initially preceded by the normal catalytic mechanism. So after the catalysis, the substrate is converted to a chemically reactive intermediate that inactivates the enzyme through the covalent modification. So in this figure, the enzyme binds to the substrate and the covalent formation is formed. So there is no product formation. So inhibitors and the enzymes. Example of the suicide inhibitors like penicillin, aspirin, serine and the parathion. Next is the reversible inhibition. It includes the competitive, non-competitive and the uncompetitive. So in competitive inhibition, the Vmax is equal to constant while the Michaelis momentum is increased. So the inhibitor and substrate are structurally same but both fight for the binding of the same active site. So in this, the competition between the active site between substrate and the inhibitor. So in this figure, the enzyme and the substrate binds to form a enzyme plus product formation, while the enzyme when binds to the inhibitor, no product formation. Example of the competitive inhibitors like statins, malonate, ethanol, sulfur drugs, etc. In non-competitive inhibition, the Vmax decreases and Km is equal to constant. So the inhibitor has no similarity with the substrate and it will not compete with substrate for active sites. It attached with the other side than the active site and inhibits the transformation of the ES into EP. So in this, when enzymes binds to the substrate forms the enzyme plus product formation. When enzyme binds to the inhibitor in other side of the other than active site, then it no product formation will take place. So example of these non-competitive inhibitors are the cyanide, diisopropyl fluorophosphate, the monoamide oxidase, etc. In uncompetitive inhibition, Vmax decreases and Km will also decreases. So the inhibitor will bind only to the ES complex, and in this, after the enzyme substrate complex formed, a conformation changes in enzyme and inhibitor binds to the ES complex and product formation is inhibited. So this is a figure of the uncompetitive inhibition. So we can conclude that in the competitive inhibition, the inhibitor binds only to a free enzyme, while in the non-competitive inhibition, the inhibitor binds either free or the enzyme substrate complex, while in the uncompetitive inhibition, the inhibitor binds only in the ES complex. So this is a graph of the Michaelis momentum plot. So this represents the V naught velocity and this represents the substrate concentration, where N is equal to normal, Ci is equal to competitive inhibition, Ni is equal to non-competitive inhibition and the Ui is equal to uncompetitive inhibition. So this is all about the enzyme inhibition and its types and Michaelis momentum plot. So thank you and keep watching.